So next we have to see about the converting here. How these are converted from the decimal to the fraction or fraction to the decimal. First I will take the decimals here, or either whichever you want to get. Okay. So now I have a 9.82, right? So first whatever the number is given now, I will write all that number. That is 982. Right? Now you write, after writing all the 3 digits here, the 3 digits, after how many digits there is a decimal? After, from the, whenever you are writing the names, when you are giving and converting that, from the right to the left you have to see there first. So you have 2 digits. So you have after 2 digits is there. So divided by, after that 2 digits is 2 zeros. That is 100. Right? The 1 should be necessary there. Okay. So 100 you have to write. So it is written, read as a 9.82. But when you are writing, it is 982 divided by 100. When you are writing in the fraction here. So next one more, it is that 14.39. Right? So write all the 4 digits. 39. So 1439, all the 4. And now you see that after how many digits there is a decimal? 2 digits. So put 2 zeros. Okay. For example, if it is given in this way, 1.439. So what you can do is 1439. You write after how many digits you have the numbers? Decimal point 1, 2, 3. Right? So 3 you write. 3 zeros. So 1439 divided by 1000 you can write. So how the decimal point is given, based on that you people have to understand and you have to write the number. Okay. For this it is 14.39. For this it is 1.439. Now it is given 0.05. So write only 5 here. Okay. Because we have only digit is 5. Others are 0. Keep only 5 there. So after decimal, how many digits? 2 digits. So put 100 there. Okay. Like that, based on that you have to make the fractions here. Now we have a fractions and now you have to write it in decimal form. So how will you write? So you have a 4 number, right? 4. So how many zeros are there? 2 zeros. Put the 2 zeros. 0, 0, 4. So 2 zeros means from the right 1, 2. So 2 digits, decimal point. With that you have to make this. So next 152 divided by 10 is it. So write first 152. Right? How many zeros are there in denominator? Only 1 zero. So 1 decimal point. So from that 1 digit, 1 decimal point. Okay. Now 2809. So keep that 2809. And how many zeros are there? 3. So 3 digits, 1, 2, 3. So you can put that 3 digits. For example, if the number is given 2809 by 10. So write that 2809. How many 1 digits? So after 1 digits. Right? Based on the denominators, how many zeros are there? Based on that, we have to count the digits and we have to keep the decimal. Here, what is the number given? That whole number will write in the numerator, and after decimal, how many numbers are there? Those will be zeros in the bottom. Like that. Just this concept be clear about that. How to convert fraction to decimal, decimal to fraction. So next we have to compare the decimals here. After comparing the decimals, we have to then make a separate that as a like and dislike. Unlike. Okay, like and unlike. Okay, so first we will see the like and. Okay, now you can see that example I have taken is 5.8, 7.2. 5.69, 7.14, 5.068, 98.702. These are the examples I have taken. Here, how these are differentiated as a like. In the fractions, we used to see as a, when the denominators are same, those are like. When the denominators are not same, those are unlike. Okay. So now, here we have to, based on the decimals. After decimal, 1 digits. After decimal, 2 digits. After decimal, 3 digits are there. Based on the digits, we have to do. Not that as a 0.8. For all 0.8 you should not. That is, after point, there should be 1 digit. If it is 1 digit, right? For example, if you make a separate of the like fractions from this row, you can see 5.8, 7.2. You can see there. these two are the like fractions if you compare the all other. Because after decimal we have a 2 digits for all, 2 and 3 digits. So if you compare for only 1 digits, these two are the like fractions. Now if you compare for the 2 digits, these two will become the like fractions, pair of like. If you compare to the next two, these two, because these are the 3 decimal places, these are the 2 decimal places, these are the single 1 decimal place. Right, for that you can add some more examples also for this. For example, 0.8 or 19.7 like that. Okay, so you can make that. So before decimal, how many digits is there you can take? You can add also, you can take 296.5. Right? So after decimal, before decimal, if it is 1 digit, 2 digits, 3 digits, whatever. But after decimal, if it is 1 digit, only these all will be known as the like fractions. Okay. Here also here. It can be taken as a 5.69 and 17.14 also. These both will become a like fractions. Here also. See, before decimal we have a single and there we have a double. But after decimal 3 digits. So after decimal 2 digits, 3 digits, based on that digits. After decimal 1 place, after decimal 2 place, after decimal 3. Like separate making the groups of that. These one separate group is called as the like fractions. So all the 2 digits, all the 1 digits when you separate, those will become a like fraction. If you compare all these three, see one more example I think. This all I think, this all will be a and this like. Because it is with the 1 is with the 1 digit, 3 digits, 3 digits, 2 digits, 3 digits, right? If you compare all these, it is more than 1 number decimal here. So those will be called as a unlike fraction. So based on the after decimal, how many digits are given? Based on the digits, it will be classified as a like and unlike decimals. So based on the here decimal places, we are going to differentiate as a like decimals and unlike decimals. Okay. These all examples, if I consider, it is a unlike. If I consider only these examples, this is a like. So based on the decimal places, means after decimal 2 digits, 1 digits based on that. Okay. So in this way you can see the examples. And you can see, observe here I have taken one more example, that is 3.3, 3.303, 3.003, sorry 033, 0.33, 3.003. You can see here it is similar here. Why it is like something similar to that? Because here you have to compare the numbers. How? These decimals you have to compare and you have to make it according to the ascending and descending order here. Means comparing and finding the greater to the smaller or smaller to the greater. Now, if I see that, I will go with the ascending. Ascending means smaller to bigger here. Okay. First I will take 3.3 you have here. Right. So here we have 3.3. Here we have a 3.303. Because as we have seen in the integers, when you come to the negatives, the values decreases. Like that only here also. Here when you start with the first place, that will be increasing to the other places there. So you can see that. We will just I'll show you here. So now before I go with this example, just I'll go with the greater decimal here. Okay. You have to find out first one, which is the greater decimal there. Then you have to go with the other one. Okay. So here it is given 24.70 and 24.58. Right. Before decimal, both the numbers are 24, but after decimal, it is 70 and 58. Obviously, you can see that 70 is greater or 58 because 0.7 is greater. 0.5 is smaller. So this is the greater one here. Okay. You can show it as in this way symbol. Okay. Now, in second one, 63.84, 63.80. Right. So 63 both the same. 0.8 and 0.8 are same, but 0.84 is given, 0.80 is given. Which is greater? This is greater because the next digit also it is given with the 4 here. Here only it is given 0. So only 8 we have. Here we have 8, 4. Means 8, 4. The 4 again 0.04 is extra extra added to that. Okay, so this is greater. Next for this 15.053, 15.5, which is greater. Don't go on the decimal place values. 3 digits are given, 1 digit is given. Don't go on that. Just go on that after decimal, the first place value what is there. So 15.053, 15.5. Place value check. First place is 5, first place is 0. So next place is nothing is given. So leave about that. We are not comparing. First place is compared after decimal. So 0 is greater or 5 is greater? 5 is greater. So 0.5. Here it is 0.05. So this is greater here. 15.5. After decimal, each place value should be compared. So here 0.8 and 0.8 both are same. We cannot say which is greater. But the second place we have 4. Second place there we have a 0. 0.04, 0.00, which is 0.04. So this is greater here. Based on the place values, but not the place digits. Place values here. If this is given in the first place, here also first place you have to check. Okay. So if, for example, if it is given 51 also, which is greater, this only. Or if it is 50 also, which is greater, that one only is greater. Okay. So we have to be clear about that. Next one more. 12.457, 12.49, which is greater because the first one is 4, place value is both equal. Second place value we have a 5, but second place value we have a 9. Third place we don't have, but don't worry about the third place. See that second place for 5 and 9. If you compare, which is 9 is greater. So 12.49 is greater. Don't go that on the digits. Here we have a 3 digits, so 457 is greater. Don't think that because reading is wrong. After decimal, it is read as 457. The single values are taken. After decimal, 4, 9 is given. 4 is equal, but whereas 5 and 9, if you compare the places you see 9 is greater. So that is greater there. Compare the next one, 6.123, 6.122. 6.12 is same, but here we have a 3, there we have a 2. So which is greater? 3 is greater. So this is greater here. Okay. If it is given 15.053, no? Here again 15.063. Which is greater? 6. Because here you can see this. First place is 0, but second place is 5. And second place is 6. 6 is greater. So 6.3 is greater. Like that. Based on that, we have to check and we have to understand how it is. Find out that which is greater. We have to compare the decimals given. If you know clear about this, then we can go with this. I will show you this. So now first what we will do here, we will take the like fractions here. Means first we will take the 1 decimal point. So 3.3. One more decimal we will do? No, only 1 decimal we have, only 1. Next one more, if you say that 2 decimals. So how many we have? We have only, that is 0.33. We make a columns and we will do it. Okay. So next now 3 decimals we will see. 1 decimal we have only 1. 2 decimal also we have only 1. So now 3 is next is 3 decimal. You will see that. So next we have a 3.303. And next here one more is 3.033. And next we have here one more 3.003. So how many we have? 1, 2, 3, 4, 5. So 3, 4, 5. 5 examples we got. Now you will see that. Now they are already in ascending order. So 3.3 is given, right? So ascending order is smaller to bigger. But if we compare that to the 1 decimal and 2 decimal, this is smaller because 0.3 is smaller than the 3. So first we will take 0.33 because before decimal we have 0. So but here we have 3 all the other examples. So this will become the first smaller decimal number. Next 3.3 is given. Before that, after decimal only 1 number is given. So compare this to the other numbers. Okay. You can see here, this is after decimal, one number that is 3 is there. After decimal we have a zeros 2 are there. You can see that? Okay. So yeah, so these first places are 0. If you compare 0, 3 is greater or 0 is greater? 3 is greater. So here we have to take the smaller one. Smaller one which is that? That is this one. So and now in these two also you have to compare again. In these two now, first place is 0, second place this is 0. And here we have a 3. So 3.003 comes first and 3.033 comes next. So first is this, second we have that is 3.003. Next we have 3.033. Next we have to compare the next one. Okay. 3.3, this is over, this is over, this is over. Then next left out is 3.3 and 3.303, right? So if nothing is there, it can be considered as only 0. After decimal, if we put how many numbers of 0 also, that will be not considered. It is the 0 itself, okay? But at the after the decimals, if nothing is there, when nothing is there, you can consider. But you can write it for this one, how many zeros you want, you can write. But not for here. This is wrong. Okay. So only when it is mentioned there. If it is given there in this way, removing that and keeping that and then we are keeping 3. That is wrong way. For this, we can consider how many zero you want. But we have to compare this 3.3 to this number, this decimal. So the other two places we can consider as 0, 0. So 3.300 if we consider also. If you compare that, what happens? 303. The third place value we have more here. So 303 is more here. So next number will be taken as 3.3. Then this is greater. The last greater number will come. Decimal number will come. That is 3.03. 303. Okay. In this way, this ascending is written. So this little it may be make you to complicate to understand, but what you have to do is listen carefully and practice. However, we have exercises. How you go on practice and makes that you to understand clear about the concept. Okay, children. This is about the writing ascending. Some more in detail. If you are writing in the descending order, the same reverse of this. From there to this one. 3.303, 3.3, 3.033, 3.003, next 0.33. Right? So like that you will have to compare here. This is ascending and descending. Ascending is smaller to bigger, descending is bigger to smaller if you compare that. This is bigger if you compare to this. This is bigger compared to this. This is bigger compared to this. This is bigger compared to this. Okay? Like that we have to see this. As we are going to discuss about the more examples, you will be more clear about the examples too. Okay?